Greetings, my little Triglets. Welcome back to another exciting day of Trig videos. All right, today we're going to do section 5.6, and it's going to be graphs of the other trig functions. So from other trig functions. All right. First of all, before we draw the graph, I want to ask you, what is the tangent of pi over 2? So if you remember your circle, hopefully that's becoming very normal to you. Here's pi over 2. Sine is, or cosine is 0, sine is 1. Tangent then of pi over 2 is 1 over 0. Now we call that undefined. And it's undefined because it's not graphable. It doesn't show up on the graph. If you try to plot that point, it doesn't exist. So I'm not going to do a big t-chart like I did with sine and cosine. You're just going to have to kind of trust me a little bit here. With tangent at all the pi over 2's, so pi over 2, 3 pi over 2, and so on, all the odd pi over 2's, there's going to be a hole in the graph. So I'm going to start out with putting some of those on here, and I'm going to do a negative one in there, and then go over here. Here's 3 pi over 2. And we're going to put dotted lines there, meaning we can't go over that part of the graph. Okay, it's out of bounds. Those are the boundary lines. You can't go over the graph. Now, if you were to do the t-chart, you would find points that go along here through the origin and up and down forever. So you can plot points. Okay, and the closer you get to pi over 2, the tighter it gets to that dotted line, but it never quite gets there. It doesn't because of the dividing by 0 factor. So that's one wave. The second wave, if I'm going to have you actually do 2 waves of tangent and cotangent, looks like that. So this is our normal tangent wave. Now it's looks a lot different than sine and cosine. Couple other things that are different. Sine and cosine, their one wave was pi or 2 pi across. For tangent, it's pi in length. So every wave is a length of pi. So that's different. So that means for the period, you're going to use pi over b rather than 2 pi over b. So you have to keep that in mind. It's a little bit different. All right, so let's say I'm going to do a real quick graph here. Let's do y equals tangent of 2x. So the 2 is my b, so I say if 2 is b, then my little formula, whoops, is pi over b, so pi over 2. So this is now my new wavelength. Before it was pi, now it's pi over 2. So I'm going to draw the same looking graph, but instead of calling these pi over 2, I have to make the total distance pi over 2. So that means half this way, half that way. So these need to be pi over 4's to get the total of pi over 2. And then if I'm going to do the next one, I have to add another pi over 2. Well, what's 1/2 plus 1/4? That's 3/4, so 3 pi over 4. And that's where we put the dotted lines. Now there's a fancy name for these dotted lines, and they are called asymptotes. Okay, asymptotes are like the boundaries. You can't go over them. So the graph of tangent is going to look exactly the same. It's just that the labels we've corrected to accommodate this 2 here. So many of our graphs are going to look the same. It's just the labels that are going to be different. Now for tangent, we also have C and D. C still moves them left and right. Left is your plus, right is your minus. D is still moving it up and down, plus and minus, just like we did with sine and cosine. So I'm not going to go through those as much. We will do some that involve that, but I want to get the other graphs drawn here first. All right, let's try y equals cotangent of x. This looks a little bit like tangent, but it goes, or it's because it's cosine over sine, it's where sine equals 0 is where the asymptotes are. So sine equals 0 at pi over 2, or pi and 2 pi, and also at 0, but that's the y-axis. And then cotangent, you can think of it as flipped over tangent. So instead of rising, cotangent is going to fall. And it's going to look like that. So that's two waves. Notice that it's still pi for one full wave, but it's just moved over and flipped around. And right now, I'm going to draw in the tangent just to show you the difference. Tangent goes here, it goes like this. So they're not exactly flip-flopping. This one goes to the origin, tangent does, but cotangent does not. So they're not just one flipped over the other. In fact, the graph that would look like this would be negative tangent, not cotangent. So be careful with that. Okay, let's look at cosecant and secant. Start with cosecant. Y equals cosecant. Remember, it's the evil twin of sine. So what we're going to do is actually use sine to graph everything, and then at the last second, we're going to flip things over, and then cosecant's going to take all the glory. That's another reason they're evil, is because sine has to do all the work, but cosine, or cosecant, takes the glory. So let's figure out where cosecant, CSC equals 0. Where does that happen? Well, if it's sine on the bottom, that would happen at pi and 2 pi and so on. Now let's draw our sine wave in here. Normally it would look like that. Put in the dotted lines, see where it crosses? That actually is the zeros, so that's why it's 1 over 0 and undefined there. Then, to actually make the cosecant graph, we're going to just take those curves and flip them over. So this red is the cosecant graph. That's one full wave. An up and a down constitutes one full wave. Okay, let's try, let's look at secant now. All right, so we're just getting the general idea of what the graphs look like here. Secant, remember, is the evil twin of cosine, so I'm going to draw the cosine graph. Normally, oops, back that up. 1, negative 1. Normally it goes like this. And the dotted lines, just like on the other one, are going to go through the zeros, because that's where it will be undefined. And then we flip these parts over. So it looks a little bit strange because our curve is a little off-center, but if I move it over, do this, then I have a full up and a full down with this one and this one. But because we usually go from 0 to 2 pi, it's going to look, you know, half and half with these two top ones. All right, so there's what secant looks like. I'm going to erase this part just so you get an idea again of what it should look like. All right, so let's do one that has a lot of changes. Let's try y equals 2 cosecant x minus pi over 2 plus 1. So first of all, the amplitude is 2 because of this. The period, there is no b, so the period's still 2 pi. The phase shift, we're going to go to the right pi over 2. Make sure you tell me which way. And then the vertical shift would be 1 up. All right, so I'm going to do these two with one step. I don't recommend doing more than A and B together at once. It just gets a little confusing with all the lines and such. All right, so let's go to 2 and negative 2 here. I know I'm going to have up 1 here, so I'm going to add another one just so I remember it's there. Okay, and then let's draw in the normal sine wave. We're going to pretend this is sine until the end, and then we're going to flip it over. All right, so normal sine wave going up to 2 and down to -2 would look like that. All right, the next thing I'm going to do is pi over 2 to the right. So I'm going to add another 3 pi here, but I'm only going to go pi over 2, only half of it. So that would be 5 pi over 2, because this is 4 pi over 2. So everything gets moved. So this moves to here, 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 and here. Connect the red dots, and it looks like a ribbon. Looks pretty cool. All right, so then, oh shoot, I shouldn't have done it in red. Oh well, we'll have to do the other one in blue or something. All right, the next step I have to do is D. It's this part. But my word of warning is you need to put in the boundary lines, the asymptotes, before you do D, because D is going to take you off of the x-axis. So I'm going to do boundary lines through the red dots. Look at that, I get automatic dotted lines. This is such a smart board. All right, and then I'm going to move it up 1. So I'm going to do that in green. So all these red dots move up 1. This one's going to move up to here. This one up to here. This one to here. And this one here. So then I'm going to draw those through there. And my very last step, which should be in red, but I'm not going to go backwards, I'll put it in blue, is to flip those over. So I'm going to flip this over and flip this over. It's kind of crazy, gets out of control a little bit. I'm going to, whoops, move my lines up so it stays within those. So the blue is our final graph. But I would like yours in red, so please try to remember that. Do as I say, not as I do. All right, we will try a couple more in class. So be prepared, bring some colored pencils, because that makes life a lot easier. And remember, Trig love is true. Ta-ta for now.